Today's lesson is on bar models. A bar model is a pictorial representation of the word problem. So let's start off by reading the word problem. Diego ate 64 grapes. Then he ate 19 more. How many grapes did he eat altogether? So what I would like to do is start off by writing down what we know. So we know that Diego ate 64 grapes. So as I create my bar for my bar model, I can label it as Diego eating 64 grapes. Then he ate 19 more. Because he ate 19 more, we are going to add that to the same bar as the original amount of grapes that Diego ate. Now in this bar model, we aren't comparing different things. We are talking about grapes and grapes. So Diego started off by eating 64 grapes, then he ate 19 grapes. So what we are trying to find in this problem is the whole. So we can call this a part whole bar model. We have two parts, 64 and 19, and the whole, which we don't know yet. So after the students set this up, we would ask them to write an equation. So for this, the equation would be 64 plus 19. The students then can use a number of different ways to solve this problem. Right now, I'm just going to use the addition algorithm. So if we do 64 plus 19, we can add 4 and 9, which equals 13. And then 1 plus 6 plus 1 equals 8. So then our answer to this was Diego ate 83 grapes altogether. And this is how you would answer a part-whole addition story problem. Now for our next one, we have another problem that we're going to do. Now for this, just the same, we're going to do bar models, which is once again a pictorial representation of the story problem. So let's read the story problem. Nico had 63 word problems to solve. He solved 35 of them. How many more word problems does Nico have left to solve? So this one is asking something a little different. So I'm still going to start by writing, or drawing rather, my bar. Now it says Nico had 63 word problems to solve. He solved 35 of them. Now in this one, we know that there is a whole, and that whole number is 63, the amount of word problems Nico had to solve. Then it says he solved 35 of them. So this, in the part-whole model, would be represented as a part, 35. And then the leftover space in the bar is the other part that we are trying to find. So this is another example of a part-whole model. Our whole is 63 and one of our parts is 35. So in class a lot of times we ask the students, if we're trying to find a part, would we use addition or subtraction? And they would yell out subtraction. If we're trying to find a whole, would we use addition or subtraction? And they would yell out addition. So in this problem, since we are trying to find a part, we would use subtraction. So they might come up with an equation, 63 minus 35. So let's go ahead and solve 63 minus 35 using the algorithm. Now, we can't do 3 minus 5, so we must rename the 6 into a 5 and add 10 to the ones. So now we have 13 minus 5. 13 minus 5 equals 8. 5 minus 3 equals 2. And our answer would be Nico has 28 word problems left to solve. So this is an example of a subtraction part-whole word problem.